All right, guys, so I told you I would help you with the Graphing Scientific Data worksheet in order to be able to put it in a graph on the computer that you could use. So the first thing you're going to want to do is open up a blank Microsoft Excel workbook. Once you open up the Excel workbook, you need to look at your worksheet, and it has a table that has the information in it for temperature and volume. It's called Table 1. So if you look up here in the top left, I've input the information for temperature and volume. All right, and if you read it, it says that experimental data provide information about the variables from specific measurements. Graphs are prepared from data. A straight line or curve is drawn using the data points as a guide. The data points are not connected in a dot-to-dot manner. Rather, the line that best fits the data is drawn. Often, scientists need to know what the value of a variable will be at a point that was not measured. So we need to make a graph that's going to show us a line that doesn't connect dot to dot, but that goes through as many points as possible, as close as it can. So this is why it's great to use a computer or a graphing calculator instead of doing this by hand, because they're going to be a little bit more accurate than we could be doing this, coming up with this information and drawing this graph by hand. So the first step in getting the graph we want to get is to left click and highlight all of our data. After that, we want to go to Insert. And remember, we don't want to connect it dot to dot. So we're going to come over here to an XY scatter. And we want to scatter with smooth lines and markers. That means that it's going to draw a best fit line for us, and it's going to mark all of our data points for us. Now, when I first click this and it makes my graph, it's not going to be pretty. You can definitely look at this. I'm going to draw it and make it bigger. This is not exactly what we were going for. Our 4 points are on here, and the only ones that graphed or connected were the two that were right next to each other. And that's not going to help us any. That's not what we need. So once this is clicked, we're going to go over here to Quick Layout. We're going to left click Quick Layout. When you left click Quick Layout, you've got a few more options here. You can make a graph with a function. We're going to go up here to the top. So it's going to show major and minor grid lines, and it's going to show what it calls a series trend line. In science, we're going to call that our best fit line. So now you can see where we have a graph. We've got all of our X and Y markers. It extends from 0 to 700 for our temperature in Kelvin. And it extends from 0 to 450 for our cubic volume. So we drew our graph, so now we need to mark the x-axis for the independent variable and the y-axis for the dependent variable. Okay, so our x-axis, we're going to double-click Axis Title. We're going to highlight it, and we are going to title this Temperature. And we need to know how we measured that temperature. We measured it in Kelvin. So labeling our x-axis has been done. Now we need to label our y-axis. So we're going to double-click the y-axis and highlight it. Our y-axis was volume. And we measured that in cubic centimeters. So now that's done. So the reason this doesn't look 100% accurate is because it has this dark line right here. This dark line is showing where these two numbers were back to back. There's really not much we can do about that. It is what it is. I hate to say that, it is what it is. But we can make this graph a little easier to read. If we want to format the trend line, We can change the transparency. I'm going to change the color to black because that's easier to see for me. And I don't want a dash type. I want a solid line. So now that's looking a little bit better to me. I feel like I can read that better. And I'm just going to expand it and make it bigger so I can see it. It's still missing one thing. We've got our key, we've got our data points drawn, our best fit line, our X and Y axis are labeled. We need to go up here to add chart element, and we need a chart title. I want it above the chart. And I need to come up with a title for this chart. So it says on our information that the data in the table below were obtained from an experiment conducted to find out how the volume of a gas changes when its temperature changes. So my title is going to be how the volume of a gas changes when the temperature changes. All right, so now I have all the elements of a graph I have to have. So you can right-click on this, and you can save as a template, or you can come up here to File and Save, and you can save this Excel document. If you save this Excel document and send it to me, it will send me this graph, which would be great, and I can give you a grade for it. That way you don't have to print it out. That way you don't have to hand draw it. You can also export this information. So if you ever are trying to make a PowerPoint or you're trying to put this somewhere else, you can copy it. And let's say I want to put it in Microsoft Word. I can open up a new Word document. And I can paste this chart directly into Word. So there's my graph directly into Word. If you want it to be a little bit cleaner, and you want to copy and paste it into Word and submit a Word document to me, that is also fine. This should come in handy for a lot of your other classes. To me, I find it a lot easier to graph on a computer than I would on paper. I'm not going to save this. I just did it as an example. All right, let's answer some of the questions. So it says, use your graph to predict values for the volume of a gas at 0K. So we're going to find 0K. And the volume at 0K is a little bit above 0, correct? So I would say if this is 50, 60, 70, 80, 90, 100, this is 10, maybe 1 or 2. Then we can find 140. So again, these are units of, this is 100, this is 200, 1, 10, 20, 30, 40, 50. That's not going to do it. 120, 40, 150, 60, 170, 80. So these are units of 20, so we need to find 140. So this is 120, 140. I'm going to follow it all the way up. And look, that was a really easy point for me to predict. So based off the trend line, when the temperature is 140 Kelvin, the volume is 100 cubic centimeters. I'm going to go to 273 because that's the next one we're looking for. So at 273 Kelvin, so this is 220, 240, 260, about halfway between 60 and 80 is 70. I'm going to follow it up, and that looks like it's roughly 190 cubic centimeters. The last two are at 400 Kelvin. So I'm going to follow that line directly up. And at 400 Kelvin, it looks to me like it crosses about halfway between these two lines. So we've got 250, 60, 70, 80, 90, 285 cubic centimeters. And then we're going to go to 600. We're going to follow it all the way up. We've got 400 cubic centimeters, 410, 420, and 430. So I could say you could go ahead and go about halfway through and say that was approximately 425 cubic centimeters. Now all you have left to do is answer the questions. Again, I said you could answer those bottom 3 questions in Schoology. That would not be a problem. So just go ahead and type it in that submit or answer box in Schoology. And make sure you submit a copy of this graph to me so I can give you credit. This is a lab grade. It should be a really quick and easy lab grade for you and should help you out to start the semester on the right foot. Thanks.